guys, welcome back to the reaction zone. In today's lesson, we're going to look at an important gas law in chemistry, Graham's law of diffusion. Before we look at Graham's law of diffusion, there are two important concepts that we need to understand. The first is diffusion, and the second is the rate of diffusion. Diffusion is the movement of a substance from a region of high concentration to a region of lower concentration. Diffusion is the reason why the smell of perfume spreads when it is sprayed. Diffusion is also the reason why cooking aroma spreads from the kitchen to other parts of the house. The rate of diffusion of a gas in layman's terms refers to how fast or how slow a gas moves. Mathematically, the rate of diffusion can be expressed as the rate of diffusion of a gas is equal to the volume of gas diffused over the time taken. Graham's law of diffusion shows the relationship that exists between the rate of diffusion of the gas and its vapor density or its molecular mass. Graham's law of diffusion can be stated as follows: that the rate of diffusion of the gas is inversely proportional to the square root of its vapor density, or the rate of diffusion of the gas is inversely proportional to the square root of its molecular mass. Mathematically, this is expressed as R is inversely proportional to the square root of D, or R is inversely proportional to the square root of M, where D represents the vapor density of the gas and M represents the molecular mass of the gas. If the variation sign is changed on the quantity sign, then there will be a constant of proportionality. This will become R is equal to K over root D, while this will become R is equal to K over root M. We can also compare the rate of diffusion of two gases. If you have two gases A and B, and you want to compare their rate of diffusion, it means that RA over RB, where RA represents the rate of diffusion of gas A, and RB represents the rate of diffusion of gas B, will be equal to root dB over root dA, where dB represents the vapor density of gas B and dA represents the vapor density of gas A. With respect to molecular mass, Ra over Rb will give us root Mb over root Ma, where Ma represents the molecular mass of gas A and Mb represents the molecular mass of gas B. Looking at this particular expression, we can clearly see that the rate of diffusion of gas A and the vapor density of gas A have an inverse relationship. In the same way, the rate of diffusion of gas B and the vapor density of gas B also have an inverse relationship. With respect to molecular mass, it is still the same. The rate of diffusion of gas A and the molecular mass of gas A have an inverse relationship, just as the rate of diffusion of gas B and the molecular mass of gas B also have an inverse relationship. If I apply the principle of sorts in mathematics, I can rewrite this expression as RA over RB is equal to root dB over dA. This is because from sorts in mathematics, root A divided by root B is equal to root A over B. Applying the same principle here, I will have RA over RB is equal to root MB over MA. Have you ever wondered why some gases move faster than others? Graham's law explains just that. If you come back to look at this expression and this other one here, starting with this, we can see that the relationship between the rate of diffusion of a gas and the vapor density is an inverse relationship. Now, this means that the heavier a gas is, meaning the greater the density of the gas, the slower will be its rate of diffusion. But the lighter a gas is, the faster will be its rate of diffusion. Using molecular mass, the explanation is still the same. The heavier the molecular mass of the gas is, the slower the rate of diffusion. The lighter the molecular mass of the gas is, the faster the rate of diffusion. Graham's law of diffusion enables us to understand why gases such as hydrogen and helium diffuse faster when compared to gases such as oxygen and carbon dioxide. The reason is because these gases are lighter than these ones. So I believe this basic explanation of Graham's law is clear. Please, do not forget to click on the like button or the subscription button to get more premium content on important topics in chemistry. Till then, see you in the next class.